Welcome to the NYNJPA weather educational video. Today's video is all about radar data and how to use it properly and when to use it at all. So first we're going to go to the National Weather Service radar. Now, there are several different places you can get your radar data from. You can go to Weather Underground, you can go to National Weather Service, you can go to your local news station. They all have, or you can go to paid services like WeatherTap, for example. They all get their data from the same location, which is the National Weather Service, or NOAA. Now, this means that when you start to see news stations call out Doppler 8000 or whatever name they want to call their radar, they don't have their own radar system. Okay, let's be very clear about that. What they do have, though, is an enhanced graphics program, basically, that gives you more detail into the raw data that they get from the National Weather Service. It's all the same data, it's just shown in a different graphical manner to make you understand what's happening in the atmosphere. So today we're going to start off with basically what is radar, and also what are the basic uses for radar data. Okay. Now, radar is pretty easy to understand. The basic idea, without getting into all the mathematical equations here, is that you're sending energy out from a point, and then you're measuring how much energy comes back to you after it hits a certain precipitation. So, for example, let's say we send a radar out and there's a thunderstorm about, let's say, 10 miles away from you. Now, the amount of energy that is reflected back gives you your radar echo. So if it's a very strong thunderstorm with very heavy rainfall, well, that's going to give you a radar echo in the 50s or 60s or even possibly 70s. Now, to understand what this scale is, okay, this is basically the decibels in Z. Okay, now let me explain this very, very carefully. The dB in dBz is basically a logarithmic scale. It doesn't really have a strong numerical value, but basically it's a mathematical equation where it's 10 times log of z divided by z 0. So z is basically the reflective factor. So I'm trying not to get too much into math here, but this is very, very important to understand. What we're basically doing here is creating a mathematical scale to measure the intensity of precipitation. And the higher the number, the heavier the precipitation. So if you get a dBz return of 55, well, that's a very heavy precipitation. If you get a return, let's say, of 10, not so much, very weak precipitation. But remember, it also depends on what precipitation you're observing. For example, rain is far more dense than snow. So if you are getting a dBz return, let's say, of 30 in a snowstorm, that's very heavy snow. Whereas in a rainstorm, it's a moderate rainfall. So you have to kind of take that into consideration when you're seeing a lot of yellows and oranges in a snowstorm. That's either very heavy snow, or it's sleet, or it's some sort of ice product where you're getting a strong return. Whereas in a strong thunderstorm, well, the yellows and oranges are strong thunderstorm, but they're not severe. That'd be in the reds here. So it depends on what weather event you're looking at and how that weather event portrays to the scale that you're dealing with here. And that's why in a lot of the public displays out there, like in your news station display or on Weather Underground, they don't really give the scale number all that much. What they do light to heavy. That way you have a better understanding of what type of precipitation rate you're dealing with here. So trying to tell someone, well, it's 30, therefore it's heavy, it really doesn't correspond very well when dealing with a snowstorm. But if you say, hey, this radar is showing heavy snow, you get it. It's heavy snow. So that's why it's very important to pick out what type of precipitation you're dealing with here. Now, as far as all this here, I'm going to break this down for you. These different choices here tell you the type of data you can get from the radar. Now, there's actually more data you could pick up from, and you can get this from paid services, for example. We're going to do the very basic ones, though. So let's start off with base. This is your base image. Now, what is base? The base image is taken at the lowest elevation scan possible. The base reflectivity is a great way to observe precipitation near the radar. Now, this is very important. If you have a thunderstorm approaching, let's say, around Williamsport or around Scranton, and you are in Trenton, and here's where your radar is located in, you're not going to get as good of a pickup of how strong this storm is because you're looking at the lowest elevation. And the lowest elevation over portions of coastal New Jersey, south central New Jersey, which is where this radar is located, compared to Scranton is far different. So what you want to do, you want to be very careful with where you're using your base radar from. If you're forecasting for a severe event and you're located in northeastern Pennsylvania, you want to use the radar that is associated with this area, because then you're going to get a better view, a better understanding of what's happening in the atmosphere with a base radar closer to your location. Understand this. When you're sending out a pulse, that pulse is lifting up into the atmosphere. So the other reason why you want to be careful where you're using your base radar data is because your elevation changes and also the distance. So you got those two corresponding factors. So you don't want to use the base radar if you're trying to forecast for a severe thunderstorm, let's say in Williamsport, Harrisburg, Scranton, or on the other side towards northeastern Connecticut or like around Hartford, because the radar, the lowest portion of that radar wave is too far out and it becomes too diffuse. So, for example, if you're forecasting for Connecticut, you want to use the radar that's based around central Long Island. Get my point? The closer you are to a location, that's where you want to focus the base radar. So if you're in New York City, you want to use New York City's base radar. If you're in southern Connecticut, New York's radar would be fine. If you're in northeastern Connecticut, you might want to consider Boston or portions of southeastern New England. There's all sorts of different choices you can select. The point is, be mindful of where this radar data is from. Okay? So that's the first part. Now, what about composite? What is that? Now, that's a great question because everyone's always wondering, well, should I use base or should I use composite? It depends on the situation you're dealing with. If you have a strong thunderstorm approaching your location, or you have heavy precipitation approaching your location that is far away, let's say 30 miles away, you want to use composite. And the reason why is because it basically takes a full scan of the atmosphere. You see, there's different levels in the atmosphere that the Doppler radar goes out to. Now, in paid data, you can actually see those different levels and select those levels to see how each section of the storm is developing. In this case, we just have composite. It just takes everything in. So in this case, we're using composite, and notice that the precipitation off the coast is covered a lot more. There's a lot more out there. Why is that? Well, remember, we're taking different levels of the atmosphere. So there's something called virga. What that basically is precipitation falling from the clouds and then drying up in a drier layer of the atmosphere. So you're able to pick up virga a lot better when you compare the composite data to the base data. Obviously, if precipitation is not reaching the ground, it's not going to show up very well in the base data. But in terms of composite, you can see that. Now, this is really important in being able to pick up, let's say, the cooling of the atmosphere ahead of a winter storm. It's also important to get a better idea and structure of a thunderstorm. So the more impressive the composite layout is of a thunderstorm, the higher up it is in the atmosphere, and also you could pick up indications like hail development and also heavy rainfall development. There's a lot of different factors that can lead up to the forecasting of these thunderstorms. So in the case of, let's say, you're dealing with higher elevations, okay? What you can use this radar data for is that you basically are able to see the different layers of the thunderstorm or precipitation event that's approaching your region, so you get a better idea of what's happening in the atmosphere from the surface to the mid levels of the atmosphere via the radar, regardless of where you are located in. Now, obviously, you want to be careful where you're using this composite data, once again, but again, it's an excellent use of data when you're using it correctly. So when you're trying to get the full breadth of a storm, or you're trying to pick up just how expansive the precipitation field is just above the surface, just above where you live, the composite radar data is a key factor in forecasting for winter storms, severe events, all sorts of interesting weather developments throughout the year. Next, we're going to talk about storm relative. Now, you might be wondering, what is storm relative? Well, basically, storm relative data is the wind relative to the storm's motion. Now, I gotta be very careful when describing this, because what you have, let's say this is really key in a severe thunderstorm, okay? The reds here are moving away from your radar. The greens are moving towards the radar. Okay, so here's your radar. So here's your greens and here's your reds. In a storm relative data feed, which is what this is, what you're basically doing is trying to see if there's a rotation in a precipitation event. For example, a thunderstorm. So if you have strong winds moving towards and away, right next to each other, that means that there's a rotation. And when you have a rotation, that obviously means what? A thunderstorm. And the stronger that rotation is, well, the stronger the thunderstorm, or should I say tornado is. So you want to use storm relative motion within a storm to pick out if a tornado or mesoscale low is developing. Now, the reason why they call it storm motion is that it's all relative to the motion of the specific storm. So if you have a storm that's lifting up, let's say from Philadelphia to New York City, and it's moving in this direction, okay? But the winds within that storm, while it's moving in that direction, are moving away and towards, and it's forming a circulation. That's how you can pick out whether or not there's a tornado developing. Now, the base is a little bit different. Base is basically the overall wind field, regardless of storm. So let's say that you have very strong southwesterly winds, okay? Those southwesterly winds, especially with around a storm event, is picked up. And again, it's the same idea. Red is towards, green is away. Now, the stronger these colors are, the stronger the winds. And you're able to pick that up based on the precipitation. So if you're seeing precipitation being pushed in one direction, that means it's moving quickly away or towards your location. So again, this all is dependent on whether precipitation is falling, how high up in the atmosphere it's falling from, and whether it's reaching the ground, and also, and this is the important part, what direction it's moving in terms of the storm relative motion. So when you want to find out those questions, you use one of these two products. Now, rainfall is pretty easy to understand. It's 1 hour total. This is the amount of precipitation via Doppler estimates of the precipitation that fell in 1 hour. So in this case, it's about a trace. Okay, this is somewhat useful, but I wouldn't go about it as 100% accurate. It's it's pretty close, but it's not foolproof. Okay, obviously, if you're having precipitation totals in an hour around an inch, it's probably pretty close to picking up that data correctly. Sometimes it's off by a little bit, obviously with some error, but obviously when you're dealing with high rates of precipitation, basically the idea here is to convey that hey, very heavy precipitation is falling, and then storm total. That's basically the precipitation for a continuous period of time. Now, it's continuously updated and it's basically within the hour without any breaks. Okay, so let's say if heavy rain's been falling for, let's say, 3 hours straight, you'll pick this up here. Okay, and it usually goes out. Usually, if it's a continuous rainfall event, it'll pick up that entire event. So, for example, let's say you're getting a snowstorm and it started Friday night and it continues on through Saturday morning. This product here, Storm Total, will pick up that entire precipitation event. But let's say you had a snowstorm which started on Friday, ended Saturday, and then another clipper came by on Sunday producing snow showers. Those are two separate events, and so it wouldn't pick up those two separate events. It would just pick up one, clear out, and then the other event. Finally, we have the long range image. And this is pretty cool to use. It's basically that what they're doing is combining all of the base images in the area and making one large map to kind of see how the whole storm is developing over a large area. Now, this again is a graphical feature. It's not necessarily a feature that is driven by a specific data node, but what it's doing is basically combining all the data at the base level from each one of these radar stations and combining it into one continuous picture. Now, as always, you can pick up different images and different layouts. This is a national view, and you could also go to regional views. Wide variety of options. You can even go out to Hawaii if you wanted to and check out the big islands out there. Looks like the radar's down. Thank you. Shut down. And let's try Guam. We just wanted to check out Guam. Let's see. Oh, look at that. Apparently it's raining in Guam. There's a lot of scattered showers out there. And go out to Puerto Rico. Not much really going on here. Puerto Rico radar is really awesome to use during the tropical season, because every so often you could pick up a hurricane or a tropical storm developing and kind of get a better idea of what's going on with development rather than just trusting on the satellite pictures. So this is an excellent product to use as well. Let's go back to the lower 48, and here we have our radar again. And again, for today, in this scenario, we have a lot of showers and thunderstorms developing out here in the plains. And you can see, here's the base. You got your precipitation. Now, what does the composite look like? It looks a little bit different, right? Base, composite. What are we seeing? Well, on the base, we have heavy precipitation. But when you go up to composite, you can see some back building developing here as these thunderstorms are becoming more intense. Storm relative? Well, not much in the way of any type of tornadic development. If we were looking for tornadoes, what you would see is a lot of red here right next to a lot of green. So let's say you'd see DBZ around 40 in the red and then negative 40, and that would be a tornado. And you can see right here, see this? This tells us where our radar is located. Okay? Let's try base. A little bit different, right? You can still see where our radar is located at. See the waves of energy going out, but you could also see where the precipitation is moving away and towards. You can see how strong the winds are. They're generally around, let's say, around 45 knots or so, which is pretty strong, right? Ranging anywhere from 5 to 45 knots in the atmosphere, these winds within this storm complex. Then as far as the rainfall total, well, it's pretty heavy out there. We're up to almost an inch of rain in portions of Tulsa, just to the south of Tulsa. But the storm total of this whole event is even more impressive. You can see that with our scale here, ranging from about, let's say, a half an inch to an inch around Tulsa, heading towards portions of south central Oklahoma, looking anywhere between 2 to as much as maybe even 4 inches of rain out here. And so basically to tell out here in the southern plains that we're dealing with a very heavy rain event with some strong thunderstorms. So heading back towards the basic again, nothing severe in nature with these thunderstorms. They're pretty strong, but they're not severe. They're not in this level yet of the reds. But we clearly have an event going on here with some strong thunderstorms developing over the southern plains with a cold front. So what I just did here was just showed you how to use all of the radar data, base and composite, and if you want to see the move, you can loop it. Look at that. You load the data, make sure you have your latest update from JavaScript, and there you go. There's your radar, and there you can see your cold front slowly slipping south and east with our heavy rainfall pushing slowly to the south and east with the cold front and very heavy rainfall and some embedded thunderstorms mixed in there. Our DBZ scale suggests heavy rainfall, but we don't really see any indication for severe thunderstorms yet. So that's how you use your radar data. If you have any questions, of course, as always, contact me at NYNJPA Weather. I'm your meteorologist, Stephen DiMartino. I hope you enjoyed this video, and as always, stay safe out there.